This first talk goes into the broad feature set of Couchbase. So many customers start off using Couchbase as a key value or a cache system, but Couchbase has much more to offer. A robust query language, 2 query engines, a full-text search, and other features as well. This is Michael Nitschinger. He leads Java SDK development at Couchbase, and he's going to provide us a concise but complete overview, and it should be a good session. So he's got lots of time to do that. He's asked me to facilitate questions through the talk, but we do need to keep the talk going, so we might iteratively kind of stop questions and then save them to the end. But if you have a question during the talk, raise your hand and I'll do my best to bring the microphone over. Michael, take it away.
Thank you very much. So, hello and welcome to this first session. As you said, my name is Michael Nitschinger. I'm based in Austria, Europe, so flew here for helping you to understand Couchbase. So, this talk is really meant as an introductory session to basically give you an overview over the different services we provide, and you'll also see links and like mentions for other sessions that will provide a deep dive into those services later on during the day. So then feel free to go there if you want to. So what are we going to cover? First, I wanted to give you a platform overview, and then we'll basically go through each service in the cluster and see where it fits into the big picture. And I'll also have some Java SDK-ish code examples, so we'll have some interactivity as well. I'm a big fan of demos, so that you get to see it in action right away. But still keeping it high level, not going into all the details because they would take way too long for today. All right, so let's get started with a platform overview. You've probably seen this diagram in the keynote before, and looking at Couchbase, where it was coming from, right? So basically, it came out of this memory first cache with persistence, replication, elasticity, and then we tagged on the different services on top, right? So what we're going to focus on today are the individual services. So we're talking about KeyValue, then query and indexing. We'll talk about full-text search. We'll talk about analytics, mobile and eventing, right? So those are the big themes. Some of those services are newer to Couchbase. Others have been there for a long time. They have evolved over time. So that's what we're going to tackle. Now, to me, that analogy, I mean, it looks interesting, but there is another analogy I'd like to draw, right? If you think of Couchbase as the human body, to me, the KV engine is like the heart of the system, right? The arteries basically feed through our TCP system into the different services, and then it eventually all flows back into KV because KV is the only service where we can do mutations, right? So even if you do a nickel query and you do an insert, it will eventually go through KV underneath, right? So it's basically this general piece. Now, the brain is the cluster manager. The cluster manager is responsible for adding nodes, removing nodes, handling failover, doing rebalance, making sure everything is in the place, right, where it should be. And then we have all those other services. For example, we have query, full-text search, analytics, and eventing. Now, I'm happy that there is not a fifth one because I have no idea where to put it. I need to get another analogy. And then there is mobile, right? So where do we put mobile? Well, just let's give this guy a phone in his hand and we'll just pretend it's mobile. And of course, we need to have the cloud in here as well. Cloud is always important. Okay, so let's talk about the platform evolution. In the beginning, and by beginning I mean like 2008, 9, 10, 11, 12, that time frame basically, where Couchbase evolved into a persisted replicated cache, right? Coming from the origins, there was memcached. Memcached was basically single node, in memory only. There was no replication, there was no persistence. Sharding was done through usually Ketama hashing, which meant if you added a new memcached node, the whole thing, basically parts of it would be invalid, so you'd have to redo your cache, warm it up again, and so forth. And at that time, people thought, okay, hey, we can actually make this thing better, and that's what Membase originally involved out of it. Basically, they took memcached added persistence, added replication, and said, hey, we'll put a sharding mechanism on top that if you add and remove nodes, your data is still there. And that's the core of the product, the KeyValue that you still see in the product right now. Of course, it got evolved over time, massively improved. We added new commands, but that basic philosophy is still there. So we added the KeyValue store, and with Couchbase Server 2.0, we added views, right? So views were the first querying mechanism, MapReduce approach to Couchbase. And then we added Couchbase Mobile. Then we added the Nickel query language in 4.0, I think. So, and then we added FullText Search. And now we added eventing and analytics. And I mean, of course, I don't need to talk about analytics that much because you've seen all of that in the keynote before. So we'll only slightly talk about it today. So if you think about it from an access pattern perspective, there are two main ways how to access the system. The first one is through the UI, right? If you are performing administrative tasks, you're an operator operating the system, you'll connect to port 8091, one node of the cluster, and you'll get presented with this very nice UI with a great interface, graphs, everything you need to operate the system. But if you're an application developer, you want to use our Couchbase SDKs, right? And we provide support for Java, .NET, JavaScript, Golang, there are many others, Python. We have a full range of SDKs that we treat as first-class citizens as part of the distributed systems. And they'll give you a consistent access and take care of the hard parts when you are talking to a distributed system. Because, for example, you have to imagine adding and removing a node while having the application talk to the cluster at the same time is pretty challenging, right? Nodes are moving around, you need to open sockets, you need to close them, you need to make sure that you always know what the current topology is. All of that is taken away from you. You use your SDK API, you call your methods that we'll see a little later, but it doesn't matter if it's 1 node or 50 node cluster, it just works, right? And that's, I think that's one of the pieces of like developing quickly with Couchbase is that you can make your prototype work locally, and then you can take your same applications and deploy it to a big production cluster, and you don't have to really make adjustments to that. And one other thing I've seen, like talking to users, answering questions in the forums, is that especially if you're coming from a relational database, you see Nickel and you think, oh, I'll always use Nickel, right? Or if you're coming from a cache-oriented background, you're thinking, oh, I always use KV because that's the fastest, right? Nickel is flexible, KV is fast. But to me, I'd like to use this analogy of the tool belt to visualize the different services in the system, right? If you're working on something at home, right, you pick a hammer, you pick a screwdriver, depending on what your need is. And with Couchbase, it's exactly the same. You should pick the right service for your use case, right? Don't just because you know SQL, try to use Nickel all the time if KV or FullText Search is a much better fit for your problem. No one is preventing you from doing that, but it's like sometimes a challenge to overcome and learn new things, even if it's in the same platform. So if you have a problem, think twice which service you're going to use. And the great thing is that the SDKs unify all those different services into one API, so you can use the same abstractions and even mix and match the different services. So you can imagine, for example, performing a FullText search query, but you're not indexing the full documents because they would just double the space requirements. So you don't index the document, and then from FullText search you get the document ID back, and then you can use KV to fetch the document if you need it, right? So you can combine services to something that's even more powerful than just each individual service. Keep that in mind as we basically walk through the individual services and their capabilities. So what we'll try to do in the next 20-30 minutes is to characterize services. And I want to do this by first give you a brief overview of what the service is about, and then we'll briefly talk about its performance requirements and use cases. Now, performance is tricky because always if someone asks, what's the performance? The answer is always, it depends. It depends on how you're using it, the data size, your operations per second that are required, throughput requirements, latency requirements. But I'm trying to give you like a ballpark figure that you can use and then drill into the specifics and adapt it to your use cases. So let's go through the services. Since this talk is called Going Forward from KV, let's of course start with KeyValue so we know what we are talking about here. What is the KeyValue service? The KeyValue service is, and this is important, it's a memory-centric distributed persistent cache. And the important part here is memory-centric. Everything that goes through KeyValue is first going through our managed cache layer, which means that we can, if the system is set up properly, we can give you very deterministic latency guarantees, right? We know, since we are always serving from memory, leaving aside other configurations like full eviction, where we are evicting everything from memory so that you can keep more data around. But in general, like, everything goes through memory, so we can be very specific to give you requirements and give you that performance consistently. Of course, we do replication. We are a distributed system, and we need to make sure that if one node goes down, your data is still available. And as you probably know, the KeyValue service gives you an API where you always need to know the key, right? So this is very important. If you don't know the key of your document, you can't access the document. This is where Nickel comes in, right? Where you say, give me all users by first name, for example, right? This is where Nickel comes into play. But if you know the document key, and the document key is up to you, you can use any key you want. For example, if you know in your system the document key, which needs to be unique, is an email address, so you can use the document key, the email address of the user, and if you have that in scope, you can basically immediately fetch the document for that user. And also importantly, it's the only real service which can handle binary data. Since there is no secondary index at this point, you can store anything you want as long as you have a key that you can access the data from, right? So you can store XML data, binary blobs, whatever you want, you can also store that via KV. Now, if you store it as JSON, as you've seen in the keynote, and if you've used Couchbase before, you will know that all the other services like FullText Search, Query, and so forth work on top of JSON. So if you're planning to add secondary indexing, FullText Search capabilities to your system, make sure to store it as JSON. But there is no one preventing you from storing both in the same bucket, for example, or creating a new bucket and using it to store PDF blobs, for example, right? Store PDF documents and then have metadata in JSON that you then use to query and find the proper documents. So there is a lot of flexibility when you're doing the application development. And one thing that has been introduced in Couchbase Server 2.0 were MapReduce views. We don't talk about them as much anymore because most of its capabilities has been subsumed by Nickel, especially with the newer indexing mechanisms that are really, really fast. MapReduce systems are disk-based, so they are inherently slower than the current GSI functionality that we have in Nickel. So if we talk about memory-centric, what does it mean? Memory-centric basically means we have our data service, and then the arteries I talked about in our human picture. This is basically TCP, our database change protocol. Every time you make a mutation on the KV layer, it basically sends it out via those TCP streams to the replicas onto the other services that then update their individual data structures like a secondary index, trees, and so forth, independently. Here you can see it goes to the replicas, it goes to our indexing service, FullText service, and so forth. This is all in memory, right? So if your cluster is set up properly, this is very fast. And on the SDK side, you can actually say, okay, please store this document, but let me know if it's properly replicated or persisted on replica nodes, so I can be sure that if one node goes down, I know my data is safe on the replicas. And when we do a failover, there is no the document is not lost, right? If that makes sense. So use cases for KV. User profile store, ad targeting, I think that the key part here is use the KeyValue API everywhere your requirement is high throughput, low latency, and or you know the key, right? So that's kind of the big picture here. And it's used for user profile store, ad targeting, session management, personalization caching, right? All those cases where you potentially need high throughput, low latency, quick access, that's where KV really, really shines. And my general advice with data modeling is that model your hot code path, right? The path that's taking the most hit in your system, model it, that you can use it through KV, right? And then all the other secondary use cases that you have, you can handle those with Nickel, right? But the most critical piece, the most critical infrastructure, if you can, model it with KV, because then you get the most highest throughput, lowest latency, deterministic performance in your system. Now, when we talk about performance, what are we thinking here? So in general, basically you can consider sub-millisecond latency on KV, right? if your network can handle it properly and so forth. But that's in general, the target is really sub-millisecond on documents, unless you're loading 20 megabyte documents from the server. And you can think of the KeyValue as like a big distributed fast hash map, right? That's technically all it is. It's, of course, under the covers, it's fancy and complicated, but from a user perspective, it's just a big hash map where you can store documents and you can load documents and you can delete them. So here is one benchmark basically I put in here. This is from our internal basically system where we keep track of performance, so we make sure we don't have performance regressions. And actual numbers are always hard because they really depend on your requirements, but you can see one thing here I wanted to show you. First, it's like there is a trend. So the left one here, so this system basically does 80% reads, 20% writes on half kilobyte JSON items with a batch size of 1,000 inserts or reads. And you can see in Couchbase Server 3.1, we did like 1.1 million operations, and with 5.0.6.0, we are at like 3.8 million operations. So you can see that even the KV layer itself got way faster in recent releases. So it's not like we are just using what we have, but we actually continue improving and making it even faster in terms of performance. Any questions on KeyValue before we move on to the other services? Okay, so then let me show you how to use that very briefly. So I got a Couchbase node running on localhost here, and if you don't know, we're basically providing you sample data sets. So one of those sample data sets is called the travel sample, which holds airports, airlines, and so forth. So it's just some data you can play around with. It has 31,000 documents. So it's not a huge bucket, but it's big enough to actually look at it and play around with it and get familiar with the system. So what we're going to do first is basically look at some very simple KeyValue operations. And I've intentionally omitted all error handling, right? So we're not going to look at that at all because it just makes it more complicated. So this is Java code. If you don't do Java, it should still be very simple. So what you can see is we are connecting to our Couchbase cluster. We authenticate with our role-based access control. Here we are just using the administrator credentials. That's something very common. If you develop locally, you just use the administrator credentials and be done with it. In a real production system, of course, that's a proper user with proper role-based access control settings and so forth. And then what we do is basically we tell our bucket, hey, get us the document with the key airline 10. And you'll see here immediately, if we don't have a key, we don't get access to the document, right? And then we load our JSON document, we print it, and then we modify its content. We just set the value modified to true, and then we replace it. So basically, we store the modified document back into the server. Very simple workflow, read the document, modify it, store it back into the server. So if we run this, basically you'll see it connecting. That's all the red stuff down here, and then at the very bottom, which it's probably hard to read down there, but basically we're just printing the document, right? So it has an ID, it has a CAS value. I'm not going to in details here, but we use it for optimistic concurrency, and then the content of the JSON document. So I said I modified the airline 10, so let's go into our UI and just take a very quick look. So we can go to our travel sample, look at the documents, and then search for airline 10. And you can see the document here. We modified it properly, right? So very simple approach. Fetch the document, modify it, read it. Really, really simple to work with. And the same thing is used, like if you have, it doesn't matter if you have thousands of operations per second, you would use the same API with KeyValue. So let's switch back to our slides here. The next thing I want to talk about is query. And I combine it with indexing because technically, even if you will manually create indexes, you will always use those two together, right? So you will create indexes, and indexes are just there to support fast querying. That's all there is, right? You can also create a primary index, and then it has to do full bucket scans, basically, but that's not very efficient. So what is query indexing about? We added it in 4.0, And what Nickel, the query engine, basically does is it basically takes Nickel, a Nickel string, passes it, creates a query plan, and then executes the query plan. And the SDKs distribute the queries that you give it all over the cluster, right? So every query node in the system will get queries eventually, so we make sure we evenly distribute the load across the query nodes, which means that if you have a query high workload, you can just add nodes to the cluster with the query service, and it will spread out the load evenly between the query nodes. And the SDK will make sure it just does that behind the scenes without taking your system down. It's like SQL, but with rich JSON extensions. And so what's the indexing thing? It's also known as GSI. So if you read Couchbase documentation, if you read GSI, it stands for Global Secondary Index. And it's basically the name for the indexing mechanism that we use behind the scenes to fuel Nickel and the query engine. And what it does is it basically pulls updates from KV. So you do mutation, it sends it to the index service, and then it will update its indexes, and then it gets used by the query engine. So how does it look like? We have our data service, and the data service sends it via our TCP stream to the index service. The index service then decides, okay, this document, is it relevant for my index? And if it is, it updates the index. And there are many other things going on, like we have index replicas, which are handled by the supervisor. We have a storage engine, so we need to persist our index structure, so that's all in here. And then what happens is at query time, the query engine asks the index basically for the data it needs. It performs a scan and then returns it to the query engine. The index service can run on the same node as the query, but it doesn't have to. Again, this is our multidimensional scaling here. So in terms of query and indexing, how does the query engine look like in a very simple and schematic fashion? Of course, there are many other things going on under the covers, but it pretty much looks like a textbook approach to basically parsing SQL, right, and executing it. So we are parsing a Nickel string, then we are creating our query plan, and then we perform a scan, which means that the query engine decides which index to use based on the query. It asks the index, hey, can you please give me the data? And then, for example, it does a range scan, right? And at the end of the index, it knows which document IDs it needs to load from KV to get the full data. Either if it's a covered index, it's basically done here saying I have all the data I need to send it back to the user. But if it's not a covered index, it needs to fetch some parts of the documents to actually fulfill the query. So it will then go to the data nodes and say, hey, give me this, this, and this, and this, and this document. We'll fetch it, and then do join operations, filter it, apply aggregates, basically create an aggregate, sort it, remove it to the offset, remove it to the limit, apply the projections, and then return it to the SDK, right? So that's all going on underneath, and you can see the distributed system at play here with calling out to the index, calling out to the data nodes. Use cases, very briefly. Traditional OLTP queries, right? So every time what you would do in a traditional SQL-ish system, that's kind of, especially if it's complex queries, that's what you want to do with Nickel here. And also, especially to distinguish it from analytics, right? You want to use Nickel for queries that, like, you do lots of queries, but they are quick to execute and they don't have huge responses, right? Because streaming those back also takes time. And if you have small queries that potentially have to walk through lots of data, you would use the analytics service for that, right? And use cases, advanced session stores, it's very nice because you can combine it with KV. You can do the hot code path with KV for a session store, and then all your other requirements, like how many users are logged in right now, right? Those questions you can then answer with Nickel. Catalog and inventory management, identity and access management. A lot of those use cases that also got mentioned in the keynote, you can basically do with Nickel and query. Now, in terms of performance, here it starts to get a little tricky to actually give you numbers, because with KV it's pretty simple, right? You fetch a document, you read it, it's very deterministic. With Nickel, suddenly we have this question, this variable of how complex is my query, right? How data I'm accessing, how big is the index, how many documents do I have to fetch? And in general, we are targeting low to high milliseconds here, right? So that's the target. And also importantly, in our UI, we basically allow you to tune your queries, right? So you can look at the visual representation of the query, right? It gives you the query plan, and you can see, okay, we spent 80% of our time in this query in scanning the index. and the rest took pretty much no time at all, right, compared to the index scan. So your next logical step is, maybe I can make my index scan faster, right? Maybe I can create a new index that indexes less amount of documents, or I have a more narrow scope, right? So that I can do my index query faster. So use the UI, use the metrics we give you to guide you in optimizing those queries if you can. So, yes? Sorry. Wait.
So if you are trying to hit application from application to Couchbase, the query plan is showing here, but
yes,
this query also shows the network time and etc.
No, so what this is showing you is basically if you execute a command in the UI, you execute a query in the UI, it basically shows you the query plan for that. If you are executing from the SDK, in general, like this is not accounting for network latency, for example, between the client and the server. This is really just the execution of the query on the server platform.
But most of the queries run from application perspective, right? In that case, how do we log this, which query and how much time it took at that particular time?
So there are ways, like you can execute specific commands to figure out how long a query really took, and you also get the metrics as part of the response from the query engine on the client. So like when you get a response back, there are some metrics. I have some simple example in a minute here, and I can show you like how to get some of those statistics out there.
So generally, this is used only for preparing the queries. That's what it is.
No, so this is basically used at development time usually to figure out where's my time spent. Of course, you can execute this in production as well, right? So you take a query that gets executed by your system, you pick it. Like for example, you can run a nickel statement that gives you the queries that took the longest. You take the query, you execute it manually, and then basically you can see how the plan got executed and where the time was spent. But it's also like getting this is a little more overhead, of course, right? So you don't want to do that all time in production. You want to only look at, it's like doing a system profile, right? If you write a Java application, you also don't want to do profiling all the time because it's expensive, right? So actually, let's see. So before we move to FullText Search, let me show you over here quickly. So let's see. In this program, we're doing a simple query, select star from travel sample, and we return 2 records. And if we execute that, we would see those 2 records, but I'll show you in a second how you can get some more stats out of it. So we return 2 documents from our data set, but in addition to just showing, basically printing what's on the row, the result object in the SDK gives you more information, right? So there's, for example, info that you can access. Let's see. So in addition to printing the rows, for example, let's print the information. And you can see here, you get basically basic information on how many results basically were returned before we applied the limit. What was the elapsed time? What was the execution time, right? So you get those basic information, and then you can later go in and basically, for example, here there is a way to print the plan as part of the query during development time. But I wouldn't do that because it's a big text blob. I would rather go take the query that you see slow, drop it in the UI, run it, and then you get this nice, basically UI visualization of where the time is spent. So looking at the code here before we move on, basically you can see it's very similar to a KV query in a sense that instead of calling get, we just use the query method. And with the other services, you will see the same pattern, right? You use query, and then you pass in your nickel query, your FullText Search query. So it's very regular, right? Even if the services do different things and they are slightly different in terms of API, we tried really hard to make them as similar as possible from an API perspective. Yes?
So if I'm loading hundreds of thousands of records from a Java program, this is the simple nickel query, and I understand you can do it simple, you can make it prepared, but there are other methods like RxJava and batch.
Okay.
So what would be the fastest way to load a lot of data?
Okay, so the fastest way to load data is always through KV, right? Because even if you execute a nickel query, under the covers, it would have to go to KV anyways. All mutations in the system are only ever performed by KeyValue, right? That's the only way to get data into the system. And you mentioned RxJava, so I think like loading hundreds of thousands of documents is a little different from traditional like load one document, store one document, right? There are a little different requirements. If you're doing big batch inserts, you want to look at things like overloading the server, for example, or overloading the clients, right? If you basically throw 100,000 operations at it in one shot, you create this spike of traffic that is very different in terms of like regular operations that are going through the system. So for batching, for example, with the Java SDK, we have more specific guidelines. Like for example, if you're using RxJava to create a batch, you need to make sure to handle back pressure exceptions because you are likely overloading the system temporarily, and you will then retry the operation until the thing has smoothed out, right? Or by default, we only open one key value connection per node because that's usually the fastest. But it could be that if you are sending a big batch against the system, it's like this pipe which gets too small, right? There is only so much you can get through a TCP packet, right? So you can open more sockets in parallel to one node, so actually you get bigger pipes, right? You can send more into it at the same time. Which is beneficial for batch operations. It's most of the time not beneficial for regular operations, because if you have less sockets, for example with KeyValue, what will happen is you'll get benefits like pipelining more operations into one TCP buffer instead of having like 10 TCP buffers that are half full, right? So you get better effects on the operating system level. So bottom line of all of this is there are ways to do it, but you need to be a little careful how to do it so that it's performant and efficient. In general, since Couchbase is like a regular database in terms of OLTP type system, we are optimizing for that by default. There are ways to make it efficient in batch operations, but you need to be a little more careful in the side effects of that, basically. But let's move on, and then I'm happy to talk about the specifics later on. So let's talk about FullText Search. So we added FullText Search a couple releases ago, and we are continuing to improve it. Like in the next release, we have a vastly improved indexing capability called Scorch, which gives you lower indexes, better query performance, and so forth. But what is FullText Search? It basically allows you to query free text in an inverted index. The inverted index is the data structure that's living underneath. And like with other services, FTS will pick up the data mutations and update its indexes. Now, what does it provide? It gives you word stemming and custom analyzers, fuzzy matching. So you can do things like, did you mean X instead of Y when performing the query, right? You can handle like if the user misspelled one character, it's still able to give your data back. With nickel, that's not the case, right? Nickel is black or white. Either the row matches or it doesn't. FullText Search is gray, right? It gives you a rating, right? It tells you how good is my result set, right? And then it allows you to score your results, right? By default, it uses TF-IDF scoring, which is just one way to do scoring. And then you can also do boosting and faceting. Faceting basically allows you to explore facets of your result set and then drill into those even further, right? So it's a completely different beast. Like if you look at it quickly, you think, oh, what's the deal, right? I can use nickel for that. But if you actually drill into the use cases, it's a very different beast than regular querying. So what can you do with it? Of course, the most obvious thing is like the search box, right? The Google box or whatever you want, right? So you give it freeform text and it gives you results back. But then in general, it's about querying freeform data, right? In general, powering text content-driven applications. You can search through XML files, code, right? You can do all kinds of cool things with it that's just not possible with a very strict query language like Nickel. And if you want to learn more, there is a great session at 1 p.m. by Steve Yen about FullText Search tips and tricks to maximize a search experience. So if you want to get into the details, attend that session, you will basically learn everything that you need to know at this point. Performance-wise, it's again different from GSI with Nickel. GSI, an index is on one node, and FTS in the background does scatter-gather. So you do a query, and then it fans out to the nodes in the cluster, gets the partial results, and returns it back to you, right? In general, performance-wise, I think it's in the low to higher millisecond range, and then again, it depends on the query. So for example, you will get vastly different performance depending on how often your term frequency comes up, right? If you have a higher term frequency in the documents, you'll probably, the FTS engine needs to do way more work than if the terms don't appear that much, right? And then another great tip is just don't index your documents because they would just double the index size. We already have it in KV. And then you can use KeyValue and the subdoc API to just fetch the parts from the document that you actually need. The only gotcha here is if you need highlighting, right? So FTS can also do highlighting. It can tell you, highlight which part of the document matched. Then you need to store that specific field because otherwise it can't do the highlighting for you. And then again, looking at the analytics query. If we, oh, sorry, not analytics, search, there we go. So a search query works very similar than a Nickel query. So basically there are different ways. I can't go into all the details, but here we're executing a search query and looking for the word beer festival with a space inside our travel sample data set. And then if we run the query, there are interesting things happening because in our data set we have landmarks that give you different information about basically like what's going up. And if we search for a beer festival in our data set, you can see that the rows that are coming back, they have something called a score. So you can see the top hit had a score of 1.5, and then the next one had a score of 0.9. And what's going on here is if you would go into the UI and look at the data, you will see that there is one document which exactly has the word beer festival in it, but then the other documents only have the word festival, for example, in them, right? So one document clearly matched more than the others. And that's also a big distinction to Nickel, right? If you are looking for something and it's not there, it just doesn't get returned. But here you get documents that are less likely, but still might be fit for your query. So I think we have 10 minutes left, so yes? Yes, FullText Search also has indexes that you create in the UI and then query it, yes. So if, yes, so
repeat the question.
Yes, so the question was, like, which fields do I need to index? And the answer is you either, if you don't know, you index the full document, but usually you know, right? You have a document with a structure, and then let's say you have one field which is called content that has a text blob with a description or something, and then you only index that field. Right, so it's up to you. You can either index one or more fields, or you can index the full document. It depends, but let's come back to that later since we have a little more to talk about, and then we can do that. Okay, so let's talk about analytics, and I'm breezing through that a little bit because you heard about that before. So what is analytics? It basically allows you to perform analytical queries without the whole extract, transform, load that you typically see when you are sending data from an OLTP system into an analytical system, right? So analytics is not a data lake, right? I don't think we have ambitions to go there, right? But I think analytics is the sweet spot in taking your data from your online transactional system, making analysis on top of it very easy, and then feeding the results back into your analytical layer, right? Instead of having petabyte in a data lake that you're figuring out what we're doing with it, right? So there's a sweet spot in between. It's the same with FullText Search. FullText Search is not as capable as Elasticsearch, right? But it gives you this 80-20 sweet spot in allowing you to index and perform FullText Search on your operational data without having to set up something different. It's heavyweight. You need to figure out the synchronization, right? So there's a sweet spot in there. Importantly, it's independent for scaling. So it has independent scaling, which is important because you want to really have your workload isolated. Because an analytics query may be heavy crunching and you don't want to have your front-end workload impacted. So here we have our traditional ETL, right? Business application, operation data into a system. We have to do ETL, send it to an analytical database, and then we do batch jobs, get it to an analytics tool. With our approach, our operational data basically feeds directly over TCP into the analytics nodes, and then we can, in real time, drive our analysis off and feed them into analytics tools, or feed them back into the operational system. Use cases, reporting, ad hoc queries, data exploration, right? And I really encourage you to check that talk out at 3 p.m. Couchbase Analytics Under the Hood. That has all the internals that you didn't get at the keynote, and you won't get from me today. Go there if you want to know how it works underneath. One final question on analytics, one final thing is that people ask, like, when do you use Nickel and when do you use analytics? And the answer is, as I mentioned before, right? Lots of queries, quick performance, Nickel, fewer queries, lots of data crunching, analytics. Here is a very, very simple example, like a benchmark we did internally, where we're using a join and group by operation with the same Nickel query and the same analytics query. And what you can see, so the blue one is analytics, and the red one is Nickel. So you can see that and basically those queries were performed over ever increasing time ranges, right? So even more data had to be crunched to generate the result. If we're talking about the 1 minute interval, Nickel was really fast, like, I don't know, 5 milliseconds, analytics took 50, because it has an overhead, right? It needs to do the crunching. But then at one day, like 5,000 records, they were kind of even at 200 milliseconds. But then as you can see, as we were going into 6 months, right? 600,000 records to crunch. Nickel took way longer, like 30 seconds, and analytics was done in 5 seconds. So use the right tool for the right job, right? If you have small data that you need to access very frequently, use Nickel. If you have lots of data to crunch, go to analytics. Don't try to shoehorn everything into one system. So very quickly about eventing. The eventing service, and again, there is a talk at 3 p.m., so you have to decide between analytics and eventing, I guess. There is a talk on eventing, and very briefly, it basically allows you to perform stateless functions, right? It is triggered through data changes. So for example, if you are performing a mutation, your event gets triggered, and then you can perform an action based on that. Many use cases as well, stock pricing, news alerts, call monitoring and alerting, many use cases. Again, check out that talk. In terms of performance, here we're also talking sub-millisecond latency, hundreds of thousands of events. Of course, if you perform Nickel queries inside a function, it may take longer, right, depending on what action you do, but the system is set up to scale out nicely as well. Finally, before we end with questions, very briefly about mobile. What is mobile? Well, mobile allows you to sync data from your cloud or on-premise system into the edge, right? Your mobile devices, your IoT system. It's scalable, and the important part is like all the sync thing that we built into it. It allows you to deal with spotty networks and devices that are offline coming online, right? Those pieces are very hard to develop on your own. It may look simple at first. I've talked to a couple users out there. They're like, oh yeah, we just do the REST API. And then they started and it was fine. But then over time, they found out, oh, there is this edge case we didn't consider. Oh, there is data inconsistency here. And then they started adding all that functionality. And basically, you get it. Years and years of engineering went into Couchbase Mobile, and there's a reason for that. It's a hard problem, right? Even if it might look simple at first. Again, a talk at 1:30 about architecting business-critical applications with Couchbase Mobile. If you're into Couchbase Mobile, check out that. Again, use cases, obviously, IoT, field service. If you have people going out there doing maintenance on devices with tablets, you can use Couchbase Mobile to get that work. It's used in storefronts. It's used for flight booking and management. So all kinds of great use cases there. Performance-wise, it really depends on what you're doing again. Like, it can scale to probably thousands of connected devices. That's fine. But usually, you'll probably be bottlenecked by the device and network performance, right? So there are very specific things you need to keep in mind when thinking about integrating with mobile. And again, if check out that talk or talk to our mobile developers here, they'll be happy to help you out with that. And interestingly, again, you see we are coming back to our services here. So Sync Gateway is the piece between our mobile devices and our backend cluster. And Sync Gateway, again, uses DCP, our others from KV, and uses KV and Nickel underneath to basically make it work, right? So even our internal services use other services underneath to give you the functionality, and you should have the same mindset, right? If you take one thing away from this talk, it's that think of the tool belt analogy. Pick the tools you want. Don't try to shoehorn everything into one service because you are familiar with SQL or you've only used KV before. Really try to think, what use case, which service does it apply, and maybe I can even combine one or more services into one to basically get the best performance and experience I want. With that, and a couple of minutes left, I think we have a couple of minutes more for questions.
Everybody's hungry. Let me bring you the mic.
Essentially, you said the KV value when we query, it's a big hash map. Can you elaborate a little further on that and how it is stored in the database, in the virtual buckets?
Yeah, so the data is, so like in the system you have one bucket, right? A bucket is kind of a logical grouping of your data, right? Even if it has resource boundaries, you say how much memory I'm allocating to the bucket and so forth. The bucket is then basically spread out across all KV nodes. And what happens is that each bucket has 1024 partitions or V buckets assigned to it. And what the cluster manager does is at runtime basically distributes those partitions across all of the nodes in the cluster. So if you started with one node, you'd have 1024 in one node, right? If you add another node, it will rebalance those 1024 into 512 on each of them, excluding replicas. Replicas, again, would double that, basically. So it makes sure to have the active and replicas distributed on the cluster. And this is also the magic trick that how we can do the online rebalance. Because what happens is that if you add a new node and click rebalance, the cluster tells the client, hey, I'm moving those partitions around. So the client knows where to go to find the new data. So it basically, while the whole thing is going on, the cluster says, okay, now I'm moving partition 3 or whatever, right? From here to here. And then in the background, it moves the data. And then the client knows basically where to go still to fetch the document. At some point, it switches over to the new one. There's some internals like how it does that properly. And then the client knows, okay, now I can go to the new node and fetch the document from there. So that's basically how you move virtual buckets between actual nodes without disruption of the actual workflow.
Hi, and thank you for your session. I have a question. You said about the limitation when we are doing full text search, right? And why do we have to do it every time? Why it's not controlled by Couchbase side, like which will be limitation of the results?
I'm not sure I understand the question.
You said that when you are doing full text search,
yes,
we don't have to forget about limit, to put the limit on the results, right? To not to show everything so that it will not be as fast as we want to be.
Yes.
So why we are doing it? Why it's not controlled by Couchbase? Like what the idea behind it?
Well, so basically the limit that you apply to the query, it's the same with Nickel, right? If you do select star from bucket and you don't apply a limit, you get the whole bucket stream basically to you, right? And there is no default, because I know, for example, Elasticsearch applies a limit so that it streams over X number of rows. I don't think we do that right now. I'd have to double check. But in general, I think applying a limit is up to you, right? You need to know how many records is enough for you, right? Someone only might need 5 records, others might need 500, right? So there is no limit. But I think most of the time it's obvious from your application, right? You know, like for example, if you make a website where you can do free-form search, you know how many results you want to display on one page, right? And that's the limit basically that you provide. Like, I'm not interested in more than 10 records because I'm only showing those on the page. But it's the same with Nickel, right? If you don't give it a limit, it will return everything that matches. With KV, it's implicit, right? You fetch one document, you get one result. But every time you go from one query to n results, and it's the same in a relation database, right? The same query might return you hundreds of thousands of records, and you need to tell the system, no, I'm only interested in the top 5, for example.
Can you limit your search results according to the score, which you
Yes, so I
showed
think
us?
it's automatically scored. Basically, it's ranked by the score. So if you apply the limit, you only get the top score, like the top end numbers. Abhinav, keep me honest, is that true?
Yeah, but my question is, if I want to see the results, which are like, let's say the first score was 1.6 and the second score was 0.8. I just want to see the results up to the score 0.8. Can
I don't think there is a way to do that.
You could actually pipe that result set into a nickel query and then filter the result set by the score then potentially, correct? Using nickel curl?
Probably, yeah. But then it's, yeah. But then you would still get the, like curl would still stream the whole thing to nickel. So I don't think there is a performant and easy way to do that right now. There might be ways, but you could even say, give me the whole thing and then just stop listening in the Java client, for example, if you get to the score. So that would also work, but then you are basically wasting computation resources and network because it just keeps you streaming stuff that you haven't asked for. So that's currently not available.